Hi learners! This video lesson deals with surface area of rectangular prisms and cylinders. In particular, it will demonstrate how to determine the total surface area of right rectangular prisms and right circular cylinders in detail. In this video lesson, we will be considering right rectangular prisms and right circular cylinders only. These are the prisms and cylinders that are upright when sitting on their bases. Real-life applications of the surface area are showcased, making the concept relatable and meaningful. Strategies in analyzing and solving problems related to the topic are shown to let you gain an understanding on how these are done so that you will be able to successfully answer geometry problems similar to these in the future. If your lesson is on solid geometry, particularly on surface area of right rectangular prisms and right circular cylinders, or if you have an assignment on this topic, or if you are preparing for a test in math, or a test in geometry in particular, or you're someone who is interested in learning math, then this video is for you. In an earlier video, we described a rectangular prism as a solid or 3D object having 4 lateral faces and 2 parallel and congruent bases as shown. Its surfaces, consisting of the 4 faces and the 2 bases as shown, resembles an empty box. To make our rectangular prism relatable to all, we will be calling our prism a box as shown here. Further examination of the box tells us that the opposite faces are also parallel and congruent aside from being rectangular in shape. In an earlier video, we mentioned that a square is a special rectangle. Thus, all in all, there are 3 pairs of opposite and congruent rectangular surfaces as shown here. Our goal today is to find the total surface area, TSA in short, of the prism or the box. The total surface area is the total area that the surfaces of a 3-dimensional object occupy in square units, like square centimeters, square meters, square feet, etc. Since the surfaces in our box are rectangles, then we just multiply the length and the width of the shape to get its area, correct? Let us open our box and see what we will get out of it. Okay, so opening the box reveals its surfaces as shown, where the surfaces numbered as 1 are the front and back lateral faces, 2, the side lateral faces, and 3, the top and bottom bases. The shape laid this way can also be visualized as a wrapping material for a gift with no overlap. How do we get the total surface area of this shape? Note that the whole shape is irregular, so we will break it down to simple and smaller number of shapes like this. Look at the diagram, learners. How many rectangles do we have now? You're correct, there are 3. The large one, the lateral faces of our box, and 2 congruent smaller ones, the bases of our box. Again, to solve for the area, we just need to multiply the length and the width of the rectangles. Let us start with the large rectangle. We will make its horizontal the length L and the vertical the width W. Now with this, the area of the large rectangle consisting of the lateral faces of the box is L times W. But let us go back to the box. Isn't it that the length of the rectangle is the perimeter of the base of the box? What about the width of the rectangle? What is this in our box? Okay, so this is the height of the box. Thus, the surface area of the lateral faces of the box is perimeter of base times the height. Since the perimeter is the sum of the lengths and the widths, the surface area of the lateral faces is therefore the sum of the lengths and the widths times the height h. Note that we still have the 2 bases. Since the bases are also rectangles, we will multiply its length and width to get its area. There are two of them, so their surface area is 2 times the product of the length and the width. The total surface area of the box or prism is therefore the sum of the surface area of the lateral faces and the surface area of the two bases. Plugging in the expression for the area of the lateral faces and the area of the bases, we have the formula in solving for the total surface area, TSA, of the rectangular prism or the box. Okay, let us work on this sample problem so you will know how it is done. Let's go. Here's the problem. Aya is wrapping a gift having a shape shown below. Aya wants to save, so she's wrapping her gift with no overlap. Part 1. How large of the wrapping material in square centimeter will she need? Option A, 84 square centimeters. Option B, 160 square centimeters. Option C, 320 square centimeters. Option D, 336 square centimeters. Part 2, if the material is 75 cents per 100 square centimeters, how much will it cost Aya in wrapping the gift? Option A, 75 cents. Option B, $3.20. Option C, $6.40. Option D, $7.68. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. What are asked in the problem, learners? Okay, here we are asked two things. First, we are to determine how large the wrapping material in square centimeters will Aya need in wrapping her gift with no overlap. And second, we're to find how much will it cost Aya in wrapping the gift if the material is 75 cents per 100 square centimeters. What are given? We're given the figure of the gift with its dimensions and the cost of the wrapper per 100 square centimeters, which is 75 cents. Okay, so we start by solving part 1 first. Here, we are to determine how large the wrapping material in square centimeters will Aya need in wrapping her gift with no overlap. What of the box or the prism is this, learners? You're correct. Wrapping a gift with the given shape and with no overlap is covering the surfaces of the entire box. Thus, to answer the question on how large of the wrapping material in square centimeters will she need would mean solving for the total surface area of the given box. Here, we're given a figure with dimensions. Let us identify what each value represents. Let us have the formula we came up with earlier for the total surface area of the box or the prism. The surface area of the lateral faces is the perimeter of the base times the height, whereas the surface area of the two bases is twice its length times its width. Plugging in the values, we have adding the lengths and widths give us 22 centimeters. And multiplying 4 centimeters and 7 centimeters gives us 28 square centimeters. Multiplying 22 centimeters and 12 centimeters gives us 264 square centimeters. Multiplying 228 square centimeters gives us 56 square centimeters. Adding 264 square centimeters and 56 square centimeters gives us 320 square centimeters. So what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option C. So the total surface area of the material that Aya will use in wrapping her gift with no overlap is 320 square centimeters. That was easy. Okay, so we move on to part 2. For part 2, we're asked how much will it cost Aya in wrapping the gift with no overlap if the material is 75 cents per 100 square centimeters. In part 1, we found that Aya will use a total of 320 square centimeters of the material to wrap her gift with. Now, if the material costs 75 cents per 100 square centimeters, then we divide 320 by 100 to find out how many groups of 100 are there in 320. This gives us 3.2. Next, we multiply 3.2 by 75 cents to get the cost for 320 square centimeter wrapper. And this gives us $7.68. So, what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option D. It will therefore cost Aya $7.68 in wrapping her gift with no overlap. That was again easy. Next, we will find out how to get the total surface area, TSA, of a right circular cylinder. The canned goods and spices that are in our kitchen are mostly in containers having the shape of a right circular cylinder like what we have here. It will help if we imagine the cylinder in our discussion as such. Here is a simplified drawing of the cylindrical container with its curved surface, circular bases, the height h, and the radius r of the circular base labeled. Opening its top and bottom part and cutting it vertically will give us this shape where the rectangle corresponds to the curved surface of the cylinder and the circles are the top and bottom bases. The space occupied by the cut shape is the cylinder's surface. How do we find its surface area? We simply have to find the area of the rectangle, the curved surface, and the area of the two circles, the bases, and then add their areas. Let us first take care of the rectangle. Recall that the area of the rectangle is length times the width, where L and W are the sides of the rectangle. Assuming that the horizontal is the length L and the vertical is the width W of the rectangle in our shape, then its area is L times W. But the length L of the rectangle is the circumference of the circular base of our cylinder, and the width W is the height of the same cylinder. Thus, the area of the curved surface is circumference of the base times the height, where the circumference is 2 pi r. Plugging in the expression for the circumference and h for the height, the surface area of the curved surface is therefore 2 pi r times h. Note that we still have two other surfaces, the two circular bases. Since the area of the circle is pi r squared, then the area of the two bases is 2 pi r squared. Adding the area of the curved surface and the area of the two bases gives us the total surface area of the cylinder. Thus, TSA, or the total surface area, is equal to 2 pi r h plus 2 times pi r squared. Take note that you must have the value of r and h to successfully find the total surface area, or TSA, of the cylinder. Here's something that I want you to be careful about, learners. Not all word problems ask for the total surface area. In some cases, it will just ask for a portion of the total surface area and not the total surface area. So, when working on a word problem, read the problem carefully and read it several times when needed to know what the problem is really asking you to look for. Let us do sample problem 2. Here's the problem. Nikki has a cylindrical flower vase made of clay. The vase is 22 centimeters tall and has a radius of 6 centimeters as shown. The vase is plain with just the color of the clay, so Nikki plans to paint its curved surface with vibrant colors. What is the area of the surface of the vase that will be painted? Write your answer to the nearest tenth of square centimeters. So figures given. Option A, 828.9 square centimeters. Option B, 829.0 square centimeters. Option C, 942.0 square centimeters. And option D, 1055.1 square centimeters. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information helps find what we're looking for. What is asked in the problem, learners? You're correct. We're asked to find the area of the surface of the vase in the nearest tenth of square centimeters that Nikki planned to paint. What are given? We're given a figure of the vase with its dimensions. The problem also states that Nikki plans to paint its curved surface only. So, Nikki plans to paint the curved surface of the vase only. Where is this in our cylinder, learners? Okay, so to answer the problem, we will therefore just consider the formula in determining the area of the curved surface, right? Here it is. So the area of the curved surface is 2 pi r times h. Plugging in the values, we have 2 pi times 6 centimeters times 22 centimeters. Multiplying 2 and 6 centimeters gives us 12 centimeters. Using 3.14 for the value of pi and multiplying it to 12 centimeters gives us 37.68 centimeters. Multiplying 37.68 centimeters and 22 centimeters gives us 828.96 square centimeters. Rounding off to the nearest tenth of a square centimeters gives us 829.0 square centimeters. So, what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option B. The area of the surface of the vase that Nikki planned to paint is 829.0 square centimeters. There you are, learners. I hope that you acquired lots of learnings in today's video. Let us summarize what we have learned today. We have learned that, first, the total surface area, TSA, is the area occupied by the surface of a solid or 3D object in square units like square centimeters, square meters, square feet, etc. Second, a rectangular prism is a solid or 3D object having 4 lateral rectangular faces and 2 parallel and congruent bases. Third, a cylinder is a solid or 3D object having 2 parallel circular bases connected by a curved surface. Fourth, the formula for the total surface area, TSA, of a right rectangular prism is the surface area of the lateral faces plus the surface area of the bases, which is the sum of the length and the width times height plus 2 times L times W, where L is the length, W is the width, and H is the height of the prism. Fifth, the formula for the total surface area, TSA, of a right circular cylinder is the surface area of the curved surface plus the surface area of the bases, which is 2 pi RH plus 2 pi R squared, where R is the radius and H is the height of the cylinder. Sixth, when solving a problem, you must read it and may read it several times when needed to know what you are looking for, to determine what are given and to figure out how the given information help find what you are looking for. 7th, when a figure is given, make use of it and modify when needed. It is there to help you analyze and solve the problem. There you are, learners. Hope this video helps. That's it for now. If you have any questions, leave a comment below. And do not forget to like, subscribe, and share this video to your peers so others will learn too. Bye.